This is 5.4. This is Sum and Differences, Day 2. Okay, so we've got, it starts off with if sine of angle A is 1/2 and cosine of angle A is greater than 0. That means that cosine, well, first of all, sine is opposite over adjacent, and cosine has got to be positive. I'm going to make a triangle from this information right here. If sine is positive and cosine is positive, it looks like angle A can be drawn in quadrant 1. So I'm going to draw a triangle right here and label this angle A. Sine is going to be opposite over hypotenuse, so this is going to be 1, 2, and this does show that cosine is going to be positive as well. So this is going to be √3, and this is angle A. So it looks like this is 30 degrees. Okay, for angle B, tangent is 3/4, so that looks like this is positive, and sine is going to be negative. So where is this going to fall? If tangent is positive, let's look at this. All students take calculus. If tangent is positive, then it can be in the first or the third, but sine has to be negative, so it cannot be here or here. Okay? So it looks like if sine is going to be negative, then it has to be in one of these quadrants. So the only place that they both overlap is going to be in the third quadrant. So that's where I'm going to draw triangle B. Oops. So here's triangle B, and we know that tangent is opposite over adjacent, so opposite is going to be 3, and this is 4. So this is a 3, 4, 5 triangle, and I don't know my angle here, which is totally fine. But it looks like all students take, so it looks like this is negative and also this is negative. So be real careful with that because sine has to be negative. Okay, now it says find the exact value of sine of A minus B. It says we're using our sum and difference properties. So you should have out your formula sheet that we've been using over the last couple of days. And we're looking at our composite arguments, sum and differences, which is at the bottom of the page. Now I'm looking for this sine of A minus B. Okay, so what we're going to be doing is finding the exact values. There's that word that we've been using all year long. Finding the exact value of sine of A minus B. So I want you to look for this formula at the bottom, and we're going to start plugging in some information. So it looks like that A minus B is equivalent to sine of A times cosine of B minus cosine of A times sine of B. So that's why I labeled these two different triangles. And really I didn't really need to know that this was 30 degrees because I'm looking at my ratios, which I already had. Okay, so let's fill in what we know. If I take sine from this first triangle, which is A, I'm going to get 1/2 times cosine from my B triangle, that's negative 4/5. I'm going to go ahead and parentheses those because I'm going to multiply first. Minus cosine from my first triangle gives me √3 over 2 times sine of my B triangle gives me negative 3/5. Now this is going to be a big deal if you don't double check your negatives when you have them not in your first quadrant. Okay? Simplifying gives me negative 4 over 10 minus, and then this one's going to be a negative 3√3 over 10. At this point, you should have a common denominator, and if you don't, then you have messed up somewhere in your triangles and finding your exact values. So you should have a common denominator. Okay, how about we go ahead and change these double negatives to a positive, and I cannot add this 4 to this 3√3 because of the radical, so this is just negative 4 plus 3 √3 over 10. And that can be my final answer. Alright, let's try next one. Okay, it says find the exact value of sine of 15 degrees. Now at this point, I have no idea what this triangle is. So I'm going to try to find some information that I do know. Like, if I drew this triangle, I don't know it. So I'm going to use my sum and difference properties again. So I could set this up and use triangles I do know, like 30 degrees or 60 or 90 or 45. So on your formula sheet, what could I use to make 15 degrees? Like using the triangles I know, I could say 45 minus 30 gives me the 15 degrees. Okay, and I know what a 45 triangle looks like and a 30 triangle looks like. Okay, and since I have sine, I have to stick with sine. So I'm going to say sine of 45 minus 30, and that is equivalent to 15. So I haven't done anything, I've just replaced. All right, so now look on your arguments, and let's find out what this is equivalent to. And that would be equivalent to sine of 45 degrees times cosine of 30 degrees minus cosine of 45 degrees times sine of 30. Okay, now we are finding exact values. So if you wanted to, you could go off to the side, draw your 45-degree triangle. This is 1, 1, root 2. And you could draw a 30-degree triangle if you needed to do so. If you don't need it, that's great. Okay, so finding sine of your 45-degree triangle is going to give you 1 over root 2. Cosine of your 30-degree gives you root 3 over 2 minus cosine of your 45 gives you 1 over root 2. And sine of your 30 gives you 1/2. Multiplying that out gives you root 3 over 2 root 2 minus 1 over 2 root 2. Okay, so again, I have a common denominator. So simplifying that gives you root 3 minus 1 over 2 root 2. You do not have to rationalize. That can be your final answer. I do want to show you this. You can rationalize, and it makes this answer a whole lot prettier. Meaning, if you do sine of 45, that is 1 over root 2. Well, 1 over root 2 is root 2 over 2. Your cosine stays the same. Again, cosine of your 45 gives you 1 over root 2, which again is root 2 over 2. I'm just rationalizing inside the problem. Your sine of 30 doesn't change. Now I'm just trying to show you how different this answer looks. When you simplify this, this gives you a root 6 over 4 minus a root 2 over 4, which gives you root 6 minus root 2 over 4. This is the rationalized answer. This is non. Are either one of these more correct? No, it's exactly the same answer. But I'm showing you that I will take either answer depending on what you want to do. Okay, so cosecant. Again, we don't have a cosecant. We don't have a triangle that shows cosecant. Okay? So we need to figure out what triangles will give us cosecant of 15 degrees. But let's see, what do we know about cosecant? Well, we could rewrite cosecant as 1 over sine of 15 degrees, couldn't we? And we just found sine of 15 degrees. So we should be good to go. If we just found sine of 15 degrees, then we can rewrite this as 1 over. So we can take either one of these answers depending on which one you like. 1 over root 3 minus 1 over 2 root 2. Leave, change, flip. Leave, change, flip. And my answer is 2 root 2 over root 3 minus 1. Or, if you like the rationalized answer, it would be 4 over root 6 minus root 2. Okay, let's try cosine of 75. So what do we know about cosine of 75? Again, I don't know the triangle. So how can we get it? How about cosine of 45 plus 30? That should give it to us. Okay, so that would give us cosine of 45 degrees. Using our arguments at the bottom of the formula sheet, we could do cosine of 45 and cosine of 30 minus sine of 45 times sine of 30 degrees. Okay, so look at your 45 and your 30-degree triangles again. Cosine of 45, again, you can rationalize or not. It's not going to matter. This is 1 over root 2 times cosine of 30 gives me root 3 over 2. Minus sine of 45 is 1 over root 2 times sine of 30 gives me 1/2. Multiplying gives me root 3 over 2 root 2 minus 1 over 2 root 2. Again, you should have a common denominator. If you don't, you've messed up somewhere. Okay, this is root 3 minus 1 over 2 root 2. Okay, for those of you who like to rationalize, the only thing that changes is this number right here, and I'm going to show you that. So rationalizing, this would be root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. So simplified, that gives you root 6 over 4 minus root 2 over 4, and a final answer of root 6 minus root 2 over 4. Okay, hopefully y'all are thinking that this looks familiar. This answer is exactly the same as your sine function, which is right here, and I did it both ways before. So why is it exactly the same as sine of 15? Well, it's exactly the same as sine of 15 because cosine of 75 degrees is a cofunction, and we used this yesterday. Whoops, I can't spell cofunction. Cofunction, oh, I was spelling right, of sine of 15 degrees. And this is why. Remember, sine 15 degrees is equal to, what you do is you say cosine of 90 minus 15 degrees, and that would give you cosine of 75 degrees. So without all of this work that we just did, we simply could have shown that sine of 15 degrees is equal to cosine of 75 degrees this way, and written our answer without showing our sum and difference properties. So it's going to be helpful if you know your cofunctions from the day before. Okay, if you have questions, let me know.